Themes, symbolism, and intents of the 3DGR Crystal game. 1. The essence of mathematical perfection and harmony. At the heart of this game lies the 3DGR Crystal, a marvel of mathematical elegance defined by its adherence to the golden ratio, 5. This geometric perfection serves as more than a mere design element. It embodies a universal principle of harmony and balance. In the game, the 3DGR Crystal transcends its static form, becoming a dynamic force that influences and interacts with its environment. Its rhombic faces and proportional diagonals are not just visual aesthetics, but the very foundation upon which the game's world is built. This crystal symbolizes the interconnectedness of mathematics and nature, highlighting how abstract concepts can shape and enhance reality. 2. Procedural worlds and the dynamic interplay of geometry and nature. The game's procedural generation techniques, incorporating Perlin noise, fractals, and heimaps, mirror the crystal's mathematical underpinnings, creating a world where landscapes evolve organically yet are deeply influenced by geometric principles. This procedural generation reflects the theme of nature's inherent geometry, where the crystal's interaction with the environment creates dynamic, ever-changing terrains. The crystal's influence on mountains, valleys, and rivers symbolizes the profound impact of underlying mathematical structures on the natural world, suggesting that beauty and complexity in nature are governed by mathematical harmony. 3. Player agency and the power of creation. Players are given the profound ability to manipulate the 3DGR crystals, merging them to terraform the land, generate resources, and craft intricate structures. This aspect of gameplay emphasizes themes of creation and transformation. The crystals are not passive objects, but active elements through which players exert control over their surroundings. This empowerment reflects a deeper narrative about the human capacity to shape and influence the world, suggesting that through understanding and applying principles of geometry, one can unlock new potentials and create beauty from complexity. 4. The living ecosystem. Integration of technology and nature. The game introduces a living, breathing ecosystem where the interaction between crystals and the environment results in real-time changes. Vegetation grows, weather patterns shift, and geological formations transform based on the player's actions. This integration of technology and nature symbolizes the symbiotic relationship between human innovation and the natural world. It highlights a vision where technological advancements, embodied by the 3DGR crystals, are harmoniously integrated into the environment, promoting a vision of sustainability and balance. 5. Emergent behavior and the unpredictability of complexity. Emergent behavior is a central theme in the game, as the interaction between crystals and terrain creates unexpected and complex outcomes. This unpredictability reflects the philosophical idea that simple rules and elements, when combined, can lead to intricate and unforeseen results. The game's mechanics celebrate the beauty of chaos and complexity emerging from structured systems, embodying the concept that the universe itself is a dynamic interplay of order and randomness. 6. The aesthetics of sacred geometry. The visual and audio design of the game draws heavily from the principles of sacred geometry. The game's landscapes, structures, and interactions are imbued with geometric patterns that echo the crystal's mathematical perfection. This aesthetic approach celebrates the idea that beauty arises from symmetry and balance. The integration of real-time OpenGL rendering enhances this visual harmony, making the mathematical elegance of the crystals palpable. The game's sound design, based on harmonic frequencies, further reinforces the theme of cosmic order and the resonance of mathematical beauty. 7. Mathematical precision as a gameplay mechanic. The use of mathematical rigor in gameplay, through vector calculations, quaternion rotations, and procedural algorithms, underscores a theme of precision and mastery. Players must engage deeply with the crystal's geometric properties to achieve desired outcomes, reflecting a narrative of skill and intellectual engagement. The game celebrates the idea that understanding and manipulating the fundamental laws of geometry allows for creative and impactful interactions with the world. 8. Exploration of creativity and problem solving. The game's design encourages exploration and problem solving through the manipulation of 3D jar crystals. Players are invited to experiment with geometric configurations, discover new interactions, and solve complex puzzles. This focus on creativity and problem-solving aligns with the broader theme of human ingenuity, demonstrating that through curiosity and experimentation, players can uncover new possibilities and solve challenges. In essence, this game is a grand exploration of how mathematical principles, particularly the elegance of the 3D GR crystal, can serve as a foundation for a richly interactive and aesthetically compelling world. It celebrates the harmony between geometry and nature, the power of creative manipulation, and the beauty of emergent complexity. Through its themes and mechanics, the game invites players to experience and contribute to a universe where mathematical precision and natural beauty are intertwined, offering a profound reflection on the intersection of abstract principles and tangible reality. The game design process: crafting an immersive 3D world using the 3D GR crystal. This project, inspired by the unique properties of the 3D golden rhombus 3D jar crystal, represents a fusion of mathematics, geometry, and emergent gameplay mechanics. At its core, the 3D GR crystal structure becomes the foundational unit of an expansive, procedurally generated game world, where the interactions between these geometric forms influence the environment in real time. By utilizing OpenGL and other open-source tools, this project aims to craft a dynamic, interactive system that bridges elegant design principles with gameplay versatility. 1. Core concept: the power of the 3D GR crystal. The design of the game hinges on the intricate geometric properties of the 3D GR crystal, a structure defined by rhombic faces and diagonals that obey the golden ratio. The game's entire world-building system derives from this crystal's mathematical perfection. The 3D GR crystal isn't just a static object in this world, but a dynamic entity that interacts with its surroundings, changing landscapes, growing structures, and even impacting the natural elements like vegetation and water bodies. The crystal, with its precise geometry, becomes the basis of the world's energy system, power storage, and environmental influence. Through the combination of multiple 3D GR crystals, players can manipulate, merge, and shape the game world, leading to emergent behaviors and creating intricate patterns of landscapes and structures. 2. Procedural generation and emergent worlds. The game's landscapes are procedurally generated, using techniques like Perlin noise, fractals, and height-maps to create vast terrains that range from mountains to valleys, oceans to desert dunes. The 3D GR crystal formations will directly influence these terrains, transforming the geography based on the crystal's orientation, scale, and interactions. Each environment will evolve dynamically, with geological formations shifting as crystals are placed or removed. Crystal clusters will form naturally over time, affecting everything from vegetation growth patterns to water flow. By incorporating physics-based simulations and noise functions, this procedural world will feel organic, yet grounded in the geometric principles that govern the 3D GR crystal. Key mechanics: procedurally generated terrains. Landscapes evolve based on the interaction of 3D GR crystals with noise functions and fractals, creating varied ecosystems. Crystal-based terraforming. Players manipulate crystals to terraform the land, shaping rivers, mountains, and forests by altering the crystal's placement and structure. Complex shape interactions. The procedural landscape interacts with the crystal formations, creating organic growth patterns in flora and fauna based on the geometric symmetries of the crystals. 3. Player interactions. Manipulating geometry. In this game, the player's role revolves around interacting with the 3D GR crystals in a highly creative and strategic way. Crystals can be manipulated, merged, or combined in various configurations to unlock new abilities or influence the environment on a grander scale. Players will explore an expansive world where different regions hold unique types of crystals with distinct properties. These crystals can merge to form complex structures, each reflecting the properties of its individual components. The game's progression system will be based on mastering the manipulation of these crystals, whether it's for energy production, environmental control, or constructing intricate, fractal-based buildings. Core gameplay elements. Merging crystals. Players combine crystals to create new structures that exhibit both visual and functional complexity. Crystal-based power systems. 3D crystals act as power sources for machines, vehicles, and settlements. Their geometric perfection allows for seamless energy distribution and storage, requiring the player to think strategically about placement and use. Shape-driven puzzle solving. Certain regions of the world may feature puzzles that require a deep understanding of the 3D crystal's geometry. Players will manipulate crystal structures to align them with the natural harmonies of the game's landscape. 4. Environment and ecology. A living, breathing world. The interaction of the 3D crystals with the environment creates a living ecosystem. Vegetation growth, weather patterns, and geological formations are all affected by the crystal's presence. As players plant or merge crystals in certain locations, they will notice shifts in the local environment. Trees grow taller, rivers change course, or mountains erode over time. By leveraging real-time physics simulations, the environment feels responsive and alive. The procedural generation is coupled with a crystal-powered system that determines how the flora and fauna of the world adapt. For instance, clusters of crystals could generate electromagnetic fields that attract or repel certain species, creating natural defenses or symbiotic relationships with local wildlife. 5. Emergent behavior and complexity. The true depth of the game emerges through the player's experimentation with the 3D crystals. As crystals combine and interact with the terrain, the landscape will change in ways that reflect both the crystal's mathematical structure and the natural world. This leads to emergent behavior, where the game's systems produce unexpected outcomes based on the player's decisions. For example, combining specific types of crystals in a mountain biome could create a cascading effect where the terrain begins to mirror fractal patterns, spiraling upwards into towering crystalline spires. This emergent behavior is driven by the core principles of the golden ratio and fractal geometry, blending mathematical precision with organic evolution. 6. Visual and audio design. To complement the mathematical elegance of the 3D crystals, the game's visual design will emphasize symmetry, balance, and harmony. The landscapes will evoke natural beauty, but will be subtly influenced by geometric patterns that reflect the presence of crystals. This could include repeating fractal patterns in the clouds, hexagonal formations in the terrain, or even crystal-based bioluminescent flora that respond to player interaction. The audio design will mirror this attention to mathematical detail. Each action involving a crystal, whether it's placed, combined, or used to influence the environment, will generate audio cues based on harmonic frequencies. The soundscape of the world will evolve as crystals are manipulated, creating a dynamic, ever-changing auditory experience tied to the player's actions. 7. A journey through geometry and narrative. The player's journey is not just about mastering the manipulation of crystals, but also uncovering the deeper narrative woven into the world. The crystals are remnants of an ancient, advanced civilization that harnessed their power to reshape reality. As the player progresses, they will discover hidden temples, ancient texts, and forgotten technologies, all tied to the mystery of the 3D crystal and its role in shaping the world. Through exploration, puzzle solving, and strategic manipulation of crystals, players will unlock new abilities, reveal ancient secrets, and ultimately decide the fate of the game's world. Conclusion: merging mathematical precision with immersive gameplay. The process of designing this game begins and ends with the 3D crystal, a structure that embodies mathematical beauty and functional versatility. By building a procedurally generated world that responds to the geometric properties of the crystals, we create a game that is both visually stunning and mechanically deep. The interplay of real-time physics, procedural generation, and emergent behavior offers players a dynamic, evolving world where their creativity and strategy are constantly rewarded. This game offers a unique blend of geometry, narrative, and exploration, providing an immersive experience where the 3D GR crystal serves as the key to unlocking a vast, complex system. Through its innovative design, this project seeks to redefine how geometry and mathematics can influence game design, offering players not just a world to explore, but one they can shape, manipulate, and control. Designing a game based on the 3D Golden Rhombus. 3D are a fusion of geometry, procedural generation, and emergent gameplay. Introduction to the concept. The foundation of the game centers around the 3D Golden Rhombus. 3D jar, crystal, a captivating geometric shape defined by the golden ratio, which not only offers aesthetic appeal but also acts as a key structural unit in the game systems. The unique geometry of the 3D GR crystal, featuring rhombic faces with diagonals that adhere to the golden ratio, forms the basis of all gameplay elements, including terrain manipulation, resource generation, and complex interactions with the environment. The vision. In this game, players navigate a world governed by the intricate mathematical properties of 3D jar crystals. Each crystal is both a physical object and a functional unit capable of interacting with its surroundings in profound ways. Using procedural generation, crystals create complex, evolving landscapes, influencing geological structures, flora, and water systems. The player's ability to manipulate and combine these crystals allows for strategic exploration, crafting, and environmental manipulation, leading to emergent gameplay possibilities. Core design process. The game's design begins with the core 3D GR crystal and its distinct geometry, as reflected in the code extracted from the thread. This code serves as the initial structure for implementing the 3D GR's behavior in a digital space using OpenGL. The process involves defining the crystal's faces, vertices, and directional vectors, while also providing functions for calculating distances, normalizing vectors, and computing vector operations and cross products. That enables seamless integration of the crystal with the game world. Key components of the game's development. 1. Procedural generation of landscapes. The game's procedural landscape is created using algorithms like Perlin noise, fractals, and HiMaps. These techniques enable the generation of dynamic terrains that feel organic and ever-changing. The terrain is populated by 3D GR crystals that interact with the environment, affecting geological formations and vegetation patterns. Noise functions and HiMaps. By applying noise functions, the game generates random yet natural terrain features such as mountains, valleys, and water bodies. The 3D GR crystals influence these landscapes by generating specific topologies when they merge or interact with other crystals, creating unique formations. Geometrical terrain modifiers. The procedural generation code can harness the geometry of the crystals, like the diagonal lengths and face orientations, to modify terrain in real time. For example, when a crystal is placed in a specific region, it may alter the HiMap to generate crystal-based caves or mountainous ridges that resemble the structure of the 3D jar. 2. Crystal interactions and complex systems. The 3D GR crystal's core functionality comes from its geometrical properties and vector-based calculations, such as products, cross products, and normalization, which are detailed in the code above. These operations allow the crystals to interact with the world in unique ways, such as structural integrity and assembly. The crystals can combine based on specific geometric rules, forming larger structures that follow natural principles like the golden ratio. These structures can influence the player's ability to build fortresses, bridges, or even transportation systems. For example, merging crystals might result in an expanded area of influence that impacts the terrain's height or creates a new water source. Environmental feedback. The crystal's interaction with the terrain and elements like water and vegetation are governed by their directional vectors and positional data. Each crystal has its positional array, PS3, and directional vectors, DR1, DR2, DR3, which are used to determine how it will affect surrounding elements, allowing for dynamic environmental changes. 3. Manipulation of crystals. The player's agency comes from their ability to manipulate the crystals. They can rotate, move, or merge the crystals to create desired outcomes. This is enabled by functions within the thread such as myAddVec3, which adds a vector to a position, or myCrossProduct3, which computes the cross product of two vectors to manipulate crystal orientation. Transformation and rotation. Crystals can be rotated and transformed using the game's codebase, affecting their placement in the landscape. For example, the myCrossProduct3 and myNormalize3 functions enable smooth rotations and adjustments to crystal orientations, allowing players to align crystals with precision to trigger specific environmental reactions. Resource generation and crafting. Crystals aren't just static objects. They hold the potential to generate resources based on their position and interaction with the environment. For example, a crystal placed in water might absorb energy to create new resources, or a crystal positioned near vegetation might cause plants to grow faster, creating a self-sustaining ecosystem. 4. Emergent behavior and gameplay. One of the most exciting aspects of the game is the potential for emergent behavior driven by the interactions between the 3DGR crystals and the environment. The more crystals players interact with and place within the landscape, the more complex the environmental systems become, allowing for dynamic ecosystems. Crystals can stimulate the growth of ecosystems based on their geometric relationships. For instance, specific crystal configurations may lead to lush forests or expansive deserts, depending on how they interact with terrain and weather systems. Weather and water systems. Crystals may also affect weather patterns, creating rain in some areas or draining water from others. By calculating the magnitude and direction of vector forces from the crystal, the game's engine can simulate wind or water flows that influence both the terrain and gameplay mechanics. 5. Undo mechanism and crystal archive. The code includes a crystal undo feature with a mechanism for archiving crystals, allowing players to experiment with crystal formations and revert mistakes. This allows for a sandbox mode where players can explore different strategies of combining crystals without fear of permanent consequences. 6. Mathematical elegance and real-time aesthetics. The heart of this game lies in the mathematical beauty of the 3DGR crystal and how it seamlessly integrates with the environment. Players are not just engaging in strategic gameplay, but are also crafting aesthetically pleasing structures that follow the principles of sacred geometry. As players build more complex structures, the geometric harmony of the crystals comes to life in stunning formations. Conclusion. The design of this game is an intricate blend of mathematical precision and immersive gameplay, using the 3D Golden Rhombus, 3DGR, crystal as its core unit. The game code developed thus far provides the essential mathematical operations needed for realistic crystal interactions, while the procedural generation systems create a living, breathing world that reacts to the player's manipulations. By combining procedural landscapes, crystal interactions, and emergent systems, this game creates a unique experience where every action shapes the world in profound ways. It's more than just a game. It's an exploration of geometry, nature, and creativity, offering players a journey into a world built on the golden ratio and the elegance of the 3DGR crystal. Designing a game around the 3D Golden Rhombus, 3D Jar, Crystal, a fusion of geometry, systems, and procedural artistry. Building a game around the 3D Golden Rhombus, 3D Jar, Crystal is a deeply engaging and ambitious endeavor. This process requires the fusion of advanced geometric principles with game development mechanics to create a dynamic, immersive world. The core of the game centers on the mathematical and aesthetic properties of the 3D Jar Crystal, which is leveraged to influence gameplay, environments, and interaction systems. Here's how this project unfolds. Step 1. Conceptualizing the core mechanics. At the heart of this game design process lies the 3D Jar Crystal, an intricate shape with faces defined by the golden ratio, phi. Each crystal possesses 6 faces, and each of those faces is a rhombus with diagonals proportional to the golden ratio. These unique geometric properties aren't just for show, they become the backbone of the game's complex systems. Crystal interactions. Each crystal can connect to its neighboring crystals based on its face directions: top, bottom, front left, front right, back left, back right. These interconnections form a web of symmetry and balance, representing energy transfer, environmental manipulation, or dynamic transformations. Procedural manipulation. The player has control over manipulating these crystals, combining them into larger, more intricate formations. The combination of multiple crystals unlocks new possibilities, such as terrain transformation, resource generation, or unlocking new game abilities. The interaction between these crystals creates emergent gameplay mechanics. Dynamic properties. Using real-time OpenGL rendering, each crystal's position, direction, and interaction with neighboring crystals are dynamically calculated. Properties like color, RGB, and position, PS3, define the look and behavior of each crystal, providing visual and mechanical feedback to the player. Step 2. Procedural generation, the world of 3D Jar crystals. To fully leverage the mathematical elegance of the 3D Jar crystal, the world around it must be equally dynamic. The game utilizes procedural generation techniques to create a living, breathing world that responds to crystal formations and evolves alongside them. Noise functions and fractals. By using Perlin noise, simplex noise, and fractal algorithms, the terrain is generated procedurally. Mountains, valleys, and plains emerge naturally, but they are influenced by the presence of crystals. For example, large formations of 3D Jar crystals might terraform the land into geometric patterns or alter the course of rivers and vegetation. Heimaps and environmental simulation. The game relies on heimaps to determine the structure of the terrain. When a player places or manipulates a 3D Jar crystal, it can alter the underlying height map data, resulting in shifting landscapes. Mountains can rise where crystals connect in certain ways, or deep chasms may form based on the arrangement of their faces and edges. Geometric influence on biomes. Different areas of the world are defined by biomes, which are shaped by crystal energy. Crystal formations may have an impact on environmental elements, such as altering the type of vegetation, the flow of water bodies, or even climate conditions. For instance, arranging crystals in a particular pattern could create a desert, while another configuration might foster a lush forest biome. Step 3. Emergent gameplay and player manipulation. One of the most exciting aspects of the game is how emergent behaviors arise from the player's manipulation of the 3D Jar crystals. The system is built around the idea that every interaction and decision by the player has a ripple effect on the game world. Player agency. The player's primary tool is the ability to rotate, move, and connect crystals. This interaction can change the crystal's properties, such as its alignment, directional vectors, and connections with other crystals, which, in turn, affects the world around it. Crystals as resources. Crystals also act as valuable resources that players can collect, harvest, or grow. Depending on the surrounding environment and crystal configurations, they might generate energy, materials, or new crystal types. This aspect adds a layer of resource management, requiring players to strategically manipulate their crystals for the best outcomes. Complex structures and signaling pathways. As players progress, they can begin combining multiple crystals to create complex structures. These structures might be used for constructing intricate buildings, mechanical devices, or energy networks. A series of crystals may also form signaling pathways that control in-game functions, such as gates, doors, or environmental systems, like a weather control device. Step 4. The math behind the mechanics. At the core of the 3DGR system lies mathematical rigor that enhances both gameplay and visual aesthetics. This math governs everything from movement to interaction and formation dynamics. Products and vector calculations. The game uses efficient geometric algorithms like products, cross products, and normalization to calculate the interaction between crystals, their faces, and the environment. For instance, when two crystals connect, the game calculates the angle between their faces, ensuring that their interactions are consistent with their geometric properties. Point-line distance. This mathematical function helps define how crystals align themselves in the 3D world. It's used to determine whether a crystal fits precisely into an existing formation or if it needs to be repositioned for optimal alignment. Quaternion rotation. To allow smooth rotation of crystals in 3D space, quaternion math is applied. This helps the player easily rotate crystals around any axis without encountering gimbal lock, enhancing the fluidity of gameplay. Procedural algorithms for color, shape, and interaction. The math behind the game also influences the visual representation of crystals. The player might use a lerp function to blend the colors of two crystals when they merge, or a remap function to dynamically change the size of crystals based on environmental factors. Step 5. Visuals and aesthetics. As the 3DGR crystal is a mathematical marvel, its visual representation is equally important. The game's aesthetic focuses on geometric patterns, symmetry, and the golden ratio's inherent beauty. Real-time rendering with OpenGL. Using OpenGL, the game renders realistic lighting and shadows on the crystals, enhancing their geometric form. The player can see how light bounces off the rhombus faces and how the world changes with crystal interactions. Geometric patterns. As the player builds with crystals, geometric patterns and symmetries begin to emerge, creating breathtaking visual designs. The more complex the crystal formations, the more intricate these patterns become. This allows players to create not just functional structures, but also visually stunning works of art. Step 6. Emergent narratives and storytelling. Finally, the game will tie these mechanical systems and geometric interactions into a larger narrative framework. Players are not just manipulating crystals for the sake of gameplay mechanics. They are delving into a world of mystery, exploration, and discovery. Crystals as lore. The 3DGR crystals are ancient relics left behind by a long-lost civilization that used them to terraform the world. As players explore the world, they uncover the secrets of the civilization, learning how to harness the full potential of the crystals. Dynamic storytelling. The story evolves based on how players interact with the crystals. The environment itself becomes a character in the narrative, shifting and changing in response to the player's actions. Through their crystal manipulation, players uncover hidden locations, ancient ruins, and mysterious artifacts. Conclusion. The design of this game revolves around the idea that mathematical elegance and geometric beauty can be the core drivers of immersive gameplay. The 3D Golden Rhombus Crystal serves not only as a visual and mechanical anchor, but also as a gateway to procedural generation, player-driven storytelling, and emergent gameplay systems. Through the fusion of OpenGL rendering, procedural terrain, and the unique properties of the 3D GR, players are invited into a world where geometry shapes reality. By blending advanced code with creative gameplay, this project represents the perfect marriage of form, function, and interactive storytelling. Designing a game based on the 3D Golden Rhombus, 3D GR, Crystal, a detailed process. The game design project emerging from this thread represents a groundbreaking fusion of mathematical elegance, geometric beauty, and interactive gameplay mechanics. At the core of the design is the 3D Golden Rhombus, 3D GR, Crystal, a geometrically precise structure that embodies the golden ratio. The crystal's intrinsic symmetry and proportions serve as the foundation for a complex, dynamic game world, where the interaction of these crystals with the environment and the player shapes the core gameplay. This process outlines the journey of turning this concept into a full-fledged game using OpenGL for rendering, procedural generation for world building, and creative gameplay mechanisms built around the manipulation of the 3D GR crystals. 1. Conceptualizing the 3D GR crystal as the foundation. The 3D GR crystal is a visually striking, mathematically defined shape that forms the building blocks of this game's world. Its defining features, such as the rhombic faces and angles proportional to the golden ratio, provide an ideal basis for a modular game system. At the core of this concept is the idea that players will interact with these crystals to construct complex structures, alter the environment, and engage in gameplay that revolves around harnessing the power of these geometric entities. Each crystal consists of multiple faces, vertices, and edges, all of which must be defined accurately to create smooth interactions and transformations in the game world. Using C++ and OpenGL, these crystals are rendered with precision, allowing for real-time manipulation of vertices, rotation via quaternions, and translation across the procedurally generated landscape. 2. Code foundations, OpenGL and procedural rendering. The implementation starts with defining the fundamental structures for the game, focusing on creating a MyCrystal object comprised of multiple faces, MyFace, and vectors, Vector 3, to represent the 3D coordinates of vertices. The following pieces of code represent the base from which these interactions and transformations are built. Vector 3 and quaternion structs handle the basic geometric operations, such as cross products, dot products, and rotation calculations. These functions are essential for determining how crystals interact with one another and their surrounding environment. MyFace struct defines each face of the crystal, storing the vertices and the face's normal vector, which is crucial for rendering correct lighting and physics interactions. MyCrystal defines the entire crystal as a collection of faces and includes translation and rotation functions, allowing the player to move and rotate crystals in the game world. By developing utility functions like MyCrossProduct3, MyDotProduct3, and MyNormalize3, the player's actions are translated into smooth transformations, enabling the seamless manipulation of 3D objects. These mathematical operations are the backbone of the crystal's movement and interaction, creating the framework for rotational symmetry and dynamic positioning. 3. Procedural generation and terrain interaction. One of the primary goals is to develop a procedurally generated game world where the terrain dynamically responds to the placement and interaction of 3D GR crystals. This terrain is generated using procedural techniques like noise functions, fractals, and height maps, ensuring each landscape is unique and endlessly explorable. Noise functions and height maps. Utilizing Perlin noise or other fractal-based noise functions, the game world's terrain is generated on the fly. Height maps are calculated and rendered in real time, creating realistic hills, valleys, and other geological features. The presence of 3D GR crystals directly affects these terrain features, deforming the landscape and altering the ecosystem around the crystals. Environmental interaction. As crystals are placed, they create ripples in the terrain. For instance, large clusters of crystals may raise mountains, form lakes, or cause vegetation to sprout around them. This creates a living, breathing world where the player's actions have direct consequences on the environment. 4. Real-time crystal manipulation and emergent behavior. The ability to manipulate and interact with the 3D GR crystals in real time is one of the central mechanics of the game. Crystals can be rotated, translated, and combined to form intricate structures, which may in turn lead to emergent gameplay behavior. The crystals are not just static objects, but active components of the game world, with their own physics and environmental interactions. Translation and rotation. Using quaternion-based rotation, quaternion, from rotation, and vector-based translation, players can seamlessly adjust the position and orientation of crystals. This is essential for creating complex structures, as precise alignment is key to achieving specific gameplay outcomes. Crystal combinations and complex structures. The Connect Crystal function allows players to merge multiple crystals. By aligning the faces of two crystals, players can combine them to form larger, more intricate structures. These structures can unlock new abilities, such as generating energy fields, manipulating gravity, or influencing the world's natural elements. Dynamic lighting and shadows. By calculating face normals and leveraging OpenGL's lighting system, the game renders dynamic lighting effects as crystals are rotated and repositioned. The reflection of light off the crystal faces adds a layer of realism, making the world visually engaging while providing crucial visual cues for gameplay. 5. Advanced gameplay systems, emergent physics, and complex interactions. The interaction between crystals and the environment, combined with the player's ability to construct larger structures, creates a system of emergent physics. This means that as players combine and manipulate crystals, the game reacts in complex and often unpredictable ways. Physics-based challenges. Some gameplay mechanics will challenge the player to use the properties of 3D GR crystals to solve puzzles. For example, aligning crystals in a certain way might generate an energy field that activates a dormant part of the environment, like causing water to flow or plants to grow. Terraforming. The 3D GR crystals allow players to terraform the landscape by generating new geological formations. When a crystal is placed near a mountain, for example, it could trigger seismic activity, reshaping the land and opening new pathways for exploration. 6. Visual representation and rendering. Using OpenGL, the visual representation of the crystals and the world is brought to life. The game makes use of modern rendering techniques, such as vertex arrays and VBOs. The Draw Crystal function utilizes OpenGL's vertex arrays to efficiently render each crystal face. With proper use of normals, lighting, and color arrays, the crystals are visually distinct, with each face having its unique texture and color. Custom shader effects. To enhance the visual appeal, custom shaders can be introduced to create unique effects such as refraction, glow, or transparency as light passes through the crystal faces. This gives each crystal a distinct, otherworldly look that plays into the game's narrative of harnessing energy from these geometric wonders. 7. Expanding the world, narrative and ecosystem. The narrative of the game is tied deeply to the presence of 3D GR crystals in the world. They act as ancient relics of a lost civilization, and the player's role is to unlock their full potential. As the player explores, the environment reacts to the crystals in mysterious ways, hinting at a deeper connection between the crystals and the world's history. Ecosystem dynamics. The presence of crystals will influence the ecosystem around them. Forests might grow around specific crystal formations, while others might trigger storms or droughts. The interplay between crystals and the environment creates a living world that feels responsive and dynamic. Procedurally generated quests. The procedural generation of quests ensures that each playthrough is unique. Objectives might involve finding specific crystals, manipulating the terrain to reach hidden areas, or solving environmental puzzles using the power of the crystals. Conclusion: a fusion of geometry, environment, and gameplay. This game design process represents the fusion of intricate geometric principles and engaging gameplay. The 3DGR crystal serves not only as a foundational unit of the game's mechanics, but also as a key to unlocking the mystery of the game's world. By integrating mathematical precision, environmental interaction, and player-driven creativity, the game offers an immersive and ever-evolving experience. Through OpenGL's rendering capabilities and the power of procedural generation, players are invited to explore a world that reacts to their actions, with endless possibilities for discovery and creation. The future development of this game promises to push the boundaries of how geometry, physics, and gameplay can intertwine to create something truly innovative and immersive. Designing a game with the 3DGR crystal at its core. In this game development journey, the 3DGR crystal, 3D Golden Rhombus, serves as the core building block around which the entire system revolves. With its perfect rhombic faces adhering to the golden ratio, this geometric marvel becomes the foundation for not just the game's visuals, but its mechanics, systems, and environmental interactions. Utilizing OpenGL as the rendering engine and leveraging various open-source tools, the game is a technical and artistic showcase of the beauty and complexity of geometry in interactive media. 1. Conceptual foundation: the 3DGR crystal as the key unit. The game world is procedurally generated, using the 3DGR crystal as its fundamental unit. This unique geometric shape is characterized by two diagonals, a minor diagonal equal to the crystal's edge length and a major diagonal related to the golden ratio, phi. This precise balance forms the foundation for a range of systems that evolve in tandem with the game's narrative and mechanics. The internal angles of 60° and 123° within the 3DGR also play a pivotal role in generating complex, emergent behaviors during gameplay. Crystal behavior and interactions. Dynamic symmetry and modular systems. The mirrored symmetry of the 3DGR allows for seamless connections between multiple crystals. This creates larger, more intricate structures that directly influence the game world. When two crystals are aligned, their diagonals intersect at right angles, forming stable and balanced networks that resemble natural crystalline formations. Geometric adaptations. The 3DGR crystals interact with each other in dynamic ways. Players manipulate these crystals to create new shapes, fractals, or geometric patterns, which alter the game environment. These changes in the landscape may cause terrain deformations, trigger environmental effects like changes in weather or vegetation growth, and impact the flow of energy throughout the game world. 2. Procedural generation. Building a dynamic world. To create a living, breathing game world, procedural generation techniques are employed. The geometry of the 3DGR crystal plays a critical role in shaping the topography, ecosystems, and even the game's architecture. Using noise functions, fractals, and height maps, the terrain is formed organically, guided by the principles of the golden ratio and symmetry inherent in the 3DGR. Procedural terrain. Height maps and noise functions. The game uses a combination of Perlin and simplex noise functions to generate terrain. The resulting height maps create mountains, valleys, and other geological features, all influenced by the underlying crystalline structure. The 3DGR crystals act as catalysts for terrain deformation, their placement and orientation dictating the shape and flow of the landscape. Fractal geometry. Since the 3DGR crystal is mathematically tied to fractal patterns, its form can be replicated on both micro and macro scales. Large-scale geological formations may echo the geometry of the crystal, while smaller clusters of crystals mimic natural patterns like snowflakes, coral reefs, or cave systems. Environmental influences. water, vegetation, and geological formations. Crystal formations interact with the environment in real time. For example, a group of 3D crystals placed near a water body might influence the flow of the water, creating new rivers or lakes. Similarly, the shape and orientation of crystals may cause certain types of vegetation to flourish or wither, depending on the environmental context. Geological formations, such as caves, mountains, or cliffs, take on crystal-like forms as a reflection of the geometry underlying the game world. 3. Player interaction, harnessing the power of the 3D. At the heart of the gameplay experience is the player's ability to interact with, manipulate, and harness the power of the 3D crystals. These interactions drive the game's core mechanics, offering a blend of creativity, problem-solving, and strategy. Crystal manipulation. Building and crafting. Players can use the 3D crystals to construct complex structures. These may be bridges, towers, or machines, all governed by the crystal's inherent geometry. As players explore the game world, they uncover new ways to connect and combine crystals, unlocking new abilities and gaining control over the environment. Energy systems. The 3D crystal's geometric properties also allow it to function as a conduit for energy. The game introduces advanced materials like graphene, enhancing the crystal's capacity for power storage and distribution. Players can build intricate energy networks, powering machines, unlocking new areas, or manipulating environmental elements. The mirrored symmetry and connection points of the 3D create efficient energy pathways, enabling players to experiment with various configurations. Emergent behavior. One of the game's most exciting aspects is the emergent behavior that arises from the interaction between 3D crystals. As players build more complex structures, these configurations begin to influence the environment in unexpected ways. For example, a network of crystals may cause a localized weather event, trigger volcanic activity, or even generate entirely new biomes. Exploration and discovery. Uncovering crystal networks. As players explore the procedurally generated landscape, they encounter natural crystal formations that hint at deeper secrets within the world. These formations are often massive, stretching across entire regions, and players must carefully manipulate them to unlock new areas or gain access to hidden resources. Dynamic environments. The player's manipulation of 3D crystals directly influences the environment. For example, placing a crystal in a specific location might alter the weather patterns in that region, while another crystal could affect the growth rate of nearby vegetation. These dynamic interactions create a constantly evolving world, shaped by both the player's actions and the underlying crystalline structure. 4. Technical implementation. OpenGL and open-source tools. At the core of the game's technical implementation is OpenGL, a powerful rendering engine that allows for real-time graphics and smooth interaction with the game world. The use of open-source tools and libraries further enhances the development process, enabling advanced graphical effects, physics simulations, and procedural generation algorithms. OpenGL rendering. Real-time lighting and shading. The game utilizes advanced lighting techniques to highlight the reflective and refractive properties of the 3D crystals. As light passes through the crystals, players witness stunning visual effects, such as prisms of color, lens flares, and dynamic shadows that shift based on the crystal's orientation. Complex geometries. The OpenGL framework allows for the rendering of highly complex geometries, such as fractal patterns and procedural terrain. This ensures that the intricate details of the 3D crystal are maintained, even when scaled to massive proportions within the game world. Physics and interactions. Physics engine integration. The interaction between the 3D crystals and the environment is governed by a physics engine, which ensures that the player's manipulations have realistic consequences. Crystals can collide, shatter, or create ripples in the surrounding terrain. all based on the laws of physics. Procedural algorithms. To generate the game's procedural world, algorithms like the Diamond Square algorithm are employed to produce varied and realistic landscapes. These algorithms are tailored to integrate with the 3D crystal's geometry, ensuring that every feature of the game world feels interconnected and harmonious. 5. Narrative integration. The mystery of the 3D crystal. The 3D crystal isn't just a gameplay mechanic, it also plays a central role in the game's narrative. As players progress, they uncover the history and origin of these mysterious crystals. The crystals are remnants of an ancient civilization that harnessed their power for both technological advancement and environmental control. As players unlock the secrets of the crystals, they gain deeper insight into the world's history and their role in shaping its future. In summary, this game development project represents a fusion of geometric precision, procedural generation, and open-source technology. The 3D crystal, with its elegant mathematical properties and dynamic symmetry, serves as the foundational unit of the game, driving both its mechanics and narrative. From the organic landscapes shaped by fractal algorithms to the emergent behaviors caused by player interactions, the game offers a rich and immersive experience, where creativity and strategy come together to unlock the full potential of the 3D jar. Designing a game based on the 3D Golden Rhombus, 3D jar, crystal as the foundational unit of a complex system is both a technical and creative endeavor. In this process, I aim to transform the mathematical elegance of the 3D jar into an immersive, procedurally generated game world where crystal structures interact with dynamic environments, shaping the game's narrative and mechanics. This journey combines the intricacies of OpenGL coding, real-time rendering, and advanced geometric computations to breathe life into a system driven by the beauty of the golden ratio. Concept: the 3D crystal as the core unit. At the heart of this game is the 3D crystal, a geometric marvel whose faces are perfect rhombuses with diagonals that reflect the golden ratio. In this game, every 3D crystal is not just a visual element, but a modular unit with profound implications. These crystals serve as building blocks within the game world, influencing the terrain, weather systems, vegetation growth, and even the physical laws that govern the universe of the game. Each 3D crystal has distinct properties. Its alignment, size, and orientation can interact with other crystals and affect the environment in real time. This allows for emergent gameplay where players can harness these properties to craft structures, manipulate landscapes, and unlock hidden potential within the world. The technical framework: OpenGL, procedural generation, and real-time rendering. The game is built using OpenGL for real-time rendering, which allows us to create visually stunning, high-performance graphics while interacting with the geometrically complex 3D crystal. We utilize the following components from the code discussed. Rendering quasi-crystal shapes. The code for rendering the quasi-crystal provides the basic structure for representing 3D crystals. The quasi-crystal and drawCrystal functions, leveraging OpenGL primitives like GLBegin and Glend, allow us to create intricate geometries and apply transformations in 3D space. Dynamic interaction with environment. The game's environment, generated through procedural techniques such as noise functions, fractals, and high maps, evolves in response to the placement and interaction of crystals. This is where the Quaternion and Vector 3 structures come into play. These functions allow the game engine to handle complex rotations, translations, and scaling of crystals, ensuring that their interactions with the terrain and other crystals feel realistic and fluid. Quaternion rotations, as demonstrated in the FromRotation function, are key to aligning crystals with precision. Players can rotate, stack, or combine crystals to form new structures, all of which affect the environment around them. Vector math utilities like MyCrossProduct3, MyDotProduct3, and MyNormalize3 are used extensively to ensure that each crystal's position and orientation are mathematically sound, providing smooth transitions and collision detection between objects. Procedural terrain manipulation. As the player places crystals, the terrain dynamically responds, forming valleys, mountains, and plateaus in real time. This is done through height maps that are recalculated based on crystal placement. The manipulation of vertices and normals within the draw crystal function will be repurposed to represent the deformation of the terrain as crystals exert force or influence their surroundings. Emergent gameplay through crystal properties. Crystals aren't just static objects. They can interact with one another. The Merge Wizard functionality discussed in the command processing code hints at future systems where multiple crystals can merge into new, more complex structures. This will be a key game mechanic, where players must experiment with different crystal combinations to unlock advanced structures or solve environmental puzzles. For example, the quaternion-based rotations will allow merged crystals to create unique geometric forms, each with distinct environmental impacts, such as altering the terrain's elevation or redirecting water flow in a river. Real-time simulation of geological and ecological systems. The player's manipulation of crystals will directly affect geological formations and ecological systems. This simulation will include dynamic water bodies that flow and reshape the landscape, vegetation that grows in response to crystal energy, and even weather systems that evolve based on crystal alignments. The procedural systems will employ noise functions and fractal patterns to generate these effects in real time, creating a world that feels both natural and otherworldly. User interface and interaction. The power of crystal manipulation. The game offers a powerful, intuitive interface where players can interact with crystals in a highly visual way. Mouse and keyboard controls. The mouse controls, as outlined in the W&D proc function, allow the player to rotate the camera, inspect crystal structures, and manipulate them within the environment. Players can drag and drop crystals, rotate them using quaternion-based rotations, and snap them into place with a satisfying click. Command processing. In-game commands, such as toggling crystal properties, undoing actions, and managing complex merges, are handled efficiently using the process command function. These commands will empower players to experiment freely, building vast crystal formations without fear of irreversible mistakes. Advanced features, emergent behavior, and complex systems. One of the most exciting aspects of this game is the potential for emergent behavior. By combining multiple crystals in creative ways, players can trigger unexpected events or create self-sustaining systems. For instance, energy fields and networks. Crystals could create energy fields that influence nearby crystals, enabling chain reactions or the creation of complex networks that simulate computational logic or energy transfer. Environmental changes. Crystals may alter the environment on a large scale. A network of crystals could raise a mountain range, create new ecosystems, or even change the flow of time within certain areas of the game world. Procedural storytelling. The game's narrative is not fixed, but evolves based on player actions. As players unlock the secrets of the 3D crystals, the game world responds with new challenges and discoveries, creating a deeply immersive experience that blends geometry and story. Conclusion: a fusion of geometry, nature, and gameplay. This game, based on the 3D crystal, is more than just a puzzle or a building game. It's an exploration of the interplay between mathematical beauty and natural systems. The 3D crystal is the perfect foundational unit because it represents a balance of elegance and complexity. By combining it with real-time procedural generation and advanced geometry manipulation, the game world becomes a living, breathing entity, shaped by the player's creativity and understanding of the crystal's potential. Through the use of OpenGL and procedural generation techniques, we are building a game that reflects the limitless possibilities of geometric exploration. Every crystal placed, every rotation made, and every structure formed contributes to the evolving tapestry of the game world, offering players a rich and rewarding experience grounded in the harmony of the golden ratio. This project represents a fusion of mathematics, art, and storytelling, pushing the boundaries of what a game can be. Designing an epic game based on the 3D jar crystal and its complex systems. The journey of creating a game using the 3D golden rhombus, 3D jar, crystal as the foundation involves leveraging its geometric elegance and structural harmony to craft an immersive and procedurally generated universe. Drawing inspiration from the mathematical beauty of the 3D jar crystal and its ability to form intricate connections, the core idea is to develop a game world where the crystal's dynamic properties directly influence not only the environment, but also the entire game mechanics. By taking advantage of OpenGL for rendering and a suite of open-source tools, this game will incorporate real-time environmental changes driven by 3D jar interactions, blending elements of natural simulation, strategy, and creative construction. The role of the 3D jar crystal in the game's design. At the heart of the game lies the 3D jar crystal, defined by its perfect rhombic geometry and its proportional alignment with the golden ratio, phi. This geometric structure, where each face is a rhombus with diagonals that follow this ratio, forms the building block of the game's procedurally generated environment. In this world, 3D jar crystals are not merely static objects, they are alive with possibility. They interact with the game's physics engine and each other in ways that reflect their mathematical properties. Whether functioning as part of natural formations, technological structures, or mystical constructs, these crystals offer the player the ability to manipulate, merge, and alter them in fascinating ways, yielding unexpected emergent behaviors. Procedural generation, a world built by crystals. The landscape itself is built using procedural generation techniques like Perlin noise, fractals, and high maps to form intricate terrain. However, in this game, terrain is shaped not just by mathematical noise functions, but by the 3D jar crystals themselves. These crystals dynamically modify the environment by interacting with the natural systems of geology, vegetation, and even water bodies. Imagine a world where mountains and valleys shift based on the formation and clustering of 3D jar crystals. A crystal might, for example, serve as the nucleus for a towering mountain peak, its symmetry echoing throughout the surrounding geography, or create flowing rivers by channeling water through its specific geometric patterns. Environmental interaction, a living ecosystem of crystals. In this game, the 3D jar crystals are responsible for shaping every facet of the ecosystem. They create habitats for life, interact with geological formations, and even affect the movement of water and the growth of vegetation. Here's where the MLX classes from the code come into play. Memory management via MLX_map. These procedural systems require efficient data management to track complex interactions between crystal formations and the environment. The MLX_map class, designed to handle memory-mapped files, allows for efficient management of the game's world data, ensuring seamless interaction between the player and the procedurally generated landscapes. Synchronization and concurrency via MLX_lock and MLX_event, as crystals dynamically modify terrain and affect environmental simulations in real time. The MLX_lock and MLX_event classes manage synchronization and ensure that actions, such as crystal interactions or environmental changes, occur without conflict. This ensures a real-time environment that runs smoothly, even with the constant reshaping of the landscape. These systems allow crystals to form dynamic structures that emerge based on the player's choices. A simple alteration to a cluster of crystals could lead to the creation of a cave system, a waterfall, or a lush forest, each interaction creating a cascade of effects that modify the game world in fascinating ways. Player interaction, manipulating crystals and the world. The player's ability to manipulate and combine 3D jar crystals lies at the core of the gameplay experience. Crystals have multiple attributes based on their geometric properties, such as energy conduction, information flow, and spatial arrangement, all of which affect how they interact with one another. Manipulation mechanisms. Positioning. Players can place or remove 3D GR crystals, influencing how the landscape around them shifts. Placing a crystal in a valley might cause the terrain to rise around it or spark the growth of a forest. Combination and fusion. Combining crystals creates new structures or amplifies existing effects. By strategically combining crystals, the player can influence larger areas of terrain, create powerful energy sources, or even build computational systems using the crystal's inherent mathematical properties. Energy and information transfer. Crystals act as conduits for energy and information within the game world. The player can use these properties to build advanced structures, such as power grids, computational networks, and environmental controls, using the functional geometry of the 3D jar. Emergent gameplay and puzzle solving. As players experiment with combining and arranging 3D GR crystals, they uncover a rich layer of emergent behavior. The interplay between crystals and the environment forms the backbone of a dynamic puzzle system. Rather than solving predefined puzzles, players discover solutions by creatively manipulating the game world. For example, a seemingly impenetrable mountain range might be dissolved or reshaped by placing the right combination of crystals in key locations, channeling energy through the environment in ways that are both visually stunning and functionally transformative. Narrative and world building. Geometry meets story. The game's narrative is deeply tied to the mathematical properties of the 3D GR crystal. Players explore a world where a long-forgotten civilization harnessed the power of these crystals to manipulate reality itself. As the player delves deeper into the game, they uncover the secrets of this ancient society, learning to harness the full potential of the 3D GR crystals to reshape the world and unlock powerful abilities. The procedural landscape, modified by the crystals, creates a rich environmental storytelling experience. Every towering structure, every shifting landscape tells a story of interaction between the crystals and the environment, reflecting the harmonious balance of geometry, physics, and natural law. Technological foundation, the code and engine. The code that drives this game is built around the principles of efficiency, concurrency, and real-time responsiveness. The MLX logging system, a robust logging system, defined in the MLX_log class, tracks player interactions and environmental changes, helping debug procedural behaviors and ensuring that the game remains balanced and responsive. Concurrency and events. The MLX_lock and MLX_event classes are essential for ensuring that player actions and crystal interactions are processed in real time, without collisions or performance issues. This enables seamless transitions between calm exploration and dynamic world transformation. The vision, fusing mathematical elegance with immersive gameplay. This game is not just about exploration or puzzle solving. It's about creating a dynamic system where the player's understanding of geometry and natural laws directly influences their ability to succeed. By fusing the mathematical elegance of the 3D GR crystal with cutting-edge procedural generation, real-time physics, and open-world exploration, this project seeks to create an experience that feels both natural and otherworldly. An experience where every choice has lasting consequences in a world shaped by the player's actions. The 3D jar crystal is more than just a building block. It is the key to unlocking the mysteries of a living world. Through its unique design, The game encourages creativity, problem-solving, and discovery, offering players the ability to craft their own stories within the crystal-powered landscape. The thematic and symbolic tapestry of the 3D GR Crystal game. The intersection of mathematical precision and aesthetic elegance. At the heart of this game lies a universe where mathematical rigor and aesthetic beauty intertwine in a harmonious dance. The 3D GR Crystal, with its geometrically intricate design, embodies the profound elegance of the golden ratio, 5. This ancient symbol of harmony and balance transcends mere numbers, becoming a living, interactive artifact that shapes the game's world and mechanics. Geometric harmony as a gameplay foundation. The game's core revolves around the 3D GR Crystal's unique geometry. Each crystal, a masterful creation of rhombic faces, each aligned with the divine proportions of the golden ratio, serves as both the game's tool and canvas. The interplay of dot products, vector calculations, and quaternion rotations isn't just technical jargon. It represents a quest for perfection. Through precise mathematical algorithms, the game breathes life into these crystals, allowing them to interact with one another and with their environment in ways that reflect their inherent symmetry and balance. Procedural landscapes and dynamic worlds. The procedural generation of landscapes and the influence of crystals upon these terrains symbolize the continuous evolution and growth of the world. By harnessing Perlin noise, fractals, and heimaps, the game creates ever-changing environments that feel organic and alive. The terrain, influenced by the placement and interaction of the crystals, morphs in real time, reflecting the crystal's ability to reshape reality itself. This dynamic interplay suggests a deeper connection between the mathematical elegance of the crystals and the natural world, where beauty and function are seamlessly integrated. Emergent gameplay and player agency. Emergent gameplay themes are central to the player's experience. Each action taken by the player, whether rotating, moving, or merging crystals, has cascading effects on the game world. The crystals' interactions lead to the creation of complex structures, dynamic ecosystems, and shifting weather patterns. This emergent behavior illustrates the power of small actions in shaping larger systems, echoing the idea that every choice has a ripple effect, mirroring the interconnectedness of natural and mathematical systems. Symbolism of crystals as catalysts for transformation. Crystals in the game are more than mere objects. They are symbols of transformation and creation. Their ability to generate resources, alter landscapes, and influence ecosystems represents a deeper narrative of change and evolution. The player's manipulation of crystals is a metaphor for human ingenuity and the quest to harness and harmonize with nature's underlying patterns. The game's focus on crafting intricate structures and managing resources reflects the broader themes of innovation, creativity, and the delicate balance between technology and the natural world. The beauty of sacred geometry and real-time aesthetics. The game's aesthetic design emphasizes the beauty of sacred geometry. As players build with crystals, they engage with complex geometric patterns that echo ancient principles of beauty and harmony. Real-time rendering with OpenGL enhances this visual splendor, making the crystal's interactions with light and shadow a feast for the eyes. The game transforms mathematical principles into a visual symphony, celebrating the elegance of geometric forms and their potential to create both functional and artistic structures. The balance of creation and undo mechanism. Incorporating a crystal undo feature and archive mechanism introduces a theme of balance between creation and recreation. This feature allows players to explore, experiment, and perfect their designs without permanent consequences. It symbolizes the iterative nature of creativity and problem-solving, where trial and error are integral to the process of mastery and innovation. Conclusion: a celebration of harmony, innovation, and beauty. Ultimately, the game is a grand celebration of the intersection between mathematical precision, artistic beauty, and interactive gameplay. It invites players into a world where the principles of sacred geometry and the elegance of the golden ratio are not just theoretical concepts, but living, breathing elements that shape their experience. Through intricate mechanics, dynamic landscapes, and visually stunning designs, the game offers a profound exploration of how harmony, innovation, and beauty can coalesce in a digital universe.